First of all, I want to thank everybody for taking time out of their busy schedules to view this webinar. We've had a lot of very, very good feedback on it over the years. Obviously, for those of you who have seen it before, we've done some revisions to it. What I can say is that for those of you, this is the first time viewing it, because Howard does go through a lot of very, very technical information. Most people I will see come back a few different times to try to glean little bits and pieces of the information or understand it a little bit better. One of the things I can say is that we do have this webinar, or a close semblance of this webinar, on demand at aiaspec.com. So for any of you that work with the architectural community or the specification community, definitely a great tool to utilize to be able to help facilitate some discussions regarding concrete moisture and moisture testing. And for those of you who would like to go back and view some of the content, again, it's not going to be exactly the same, but there is a lot of the same types of content in it. For those of you who don't know me, my name is Jason Spangler. I'm the flooring division manager here at Wagner. I'm responsible for not only the concrete side of stuff, but I'm responsible for the small line of hand meters that we have for testing wood subfloor, wood finished products, or basically wood of any type. We're going to do a Q&A. I'll get to as many of the questions as I can. If for some reason I don't get to your question, or I don't answer it to the degree that you feel satisfied with, please contact me directly at 800-634-9961, extension 235. The other thing is too, as we're going through this, definitely enter in your questions, and I'll get to as many of them as possible. So without any further ado, we'll start off. Looks like we have one from, I hope I'm saying it right, Micah. Your probes are now needed to be verified or recalibrated. I'm guessing you're referencing probes in general. For us specifically, we have what's called the RapidRH 4.0 system, and we also have the RapidRH 5.0 system. Now, both of these products are definitely very critical. They're both very usable in the field, but they're two different types of systems. They're both intended to meet the F2170 standard, but they're definitely meant, and there's different nuances to each system. So first off, with the RapidRH 4.0, it is a single usage product, meaning that that sensor is going to be put, the sensor and sleeve, which is a patented design, is going to be put into one hole. It's not intended to come out at all. So the measuring device, the sleeve, nothing is intended to come out and go to a different hole. Nice side of that is the fact that it comes with a NIST traceable certificate of calibration. So the burden of you having to prove accuracy of the product, or that it meets the standard specifications outlined in the ASTM standard, is with that NIST traceable certificate. It's only going into one hole. The 5.0 system is going to be a reusable sensor. Cosmetically, if you were just to look at it from the outside and compare the 4.0 sensor and the 5.0 sensor, they look very, very, very similar. But how the pieces come together and how they come apart, definitely different. So the sensor itself, the measuring device, can be utilized over and over again. Downside to that, obviously, is the fact that you have to go through and re-verify calibration, putting the sensor onto a salt solution every 30 days or 30 days prior to each usage. So you need to make sure you have that QC process in place. The other thing is that those sensors will need to be sent back to us to be rebuilt, and there will be a cost associated with that annually. So there is more of a time commitment with a reusable sensor. In our opinion, the 5.0 system, or any reusable system, really is intended for a very small niche of the community, if you will, out there, for people who are doing concrete testing exclusively, QA laboratories or laboratories in general, People that are really dialed into and understand some of the QC processes and calibration verifications and things like that, the other people that are using a lot of our products, their ultimate goal is to install some finish on top of the concrete. And really, that's where they make their money. Their money's not usually going to be made in trying to go through and verify or re-verify instrumentation accuracies. So I hope that answered the question. What about environmental conditions, HVAC, or when sealers or curing compounds are present? Well, so I'll start off, these are kind of across the board a little bit. Environmental conditions. The ASTM standard says that you need to have conditions, ambient conditions, at what they call service conditions. So the best way that I can tell people that is that if you were to walk into, let's say it's a gymnasium. If you were to walk into a gymnasium that's functioning right now, that's in operation, and you were to take a thermohydrometer and measure the relative humidity and the temperature in the air, that would be quote unquote service condition. This is a gym that is in service and being used. If you were then to take that information and go to a building that was under construction, and you were able to measure those conditions consistently over 48 hours prior to testing, and over the entire 72 hours that the test was being conducted, then you will have met service conditions. There's nothing in the standard that says that HVAC specifically has to be on, but you have to have conditions, or you have to have a way of keeping those conditions consistent, and they need to meet what an in-service building would be like. Obviously, HVAC is on and up and functioning, and a fully enclosed building is going to be the easiest way to do that. When sealers or curing compounds are present, from a measuring standpoint or from a relative humidity standpoint, curing compounds and sealers have nothing to do or have no impact on the relative humidity testing. In essence, when you look at the science behind relative humidity testing, with a slab drying from one side, if you were to install a low permeable membrane on top of the floor, taking a measurement at 40% with that membrane on or that membrane off, from a scientific standpoint, doesn't change. That's why that 40% depth measurement is so specific or so critical, is because when you measure at that 40% mark, again, slab drying from one side, that number that you get at that 40% mark is the number that is going to equalize from top to bottom throughout the slab. So in essence, before you install, you're able to know what the relative humidity is going to be like on the surface before you do anything. That's the whole premise behind relative humidity testing. Isn't there still air displacement when checking your probes? Again, with a 4.0 sensor, if you're using a 4.0 sensor, you're going to take that sensor, you're going to put it in there, and it's all one piece when it goes in. Is there air displacement at that time? Sure, there's going to be some air displacement, because obviously you're going to be pushing the air out of the hole. But you're not going to be taking a measurement right away, as opposed to if you use a reusable sensor, you have an empty sleeve in there and a cap. So when you take the cap off of there, then you have ambient conditions that get down there. And so as you're putting the sensor in there to measure, then yes, you have air displacement. You have an equilibration time that has to happen once you put the sensor in there. For the 4.0 system that we have, the sensor is in the hole the entire time. So when you get to that point of being 72 hours, the sensor is acclimated that entire time to the hole. Flatness of the bottom of the hole, does it differ results? What we're looking at is we're looking at doing from the shoulder of the hole is where you start your 40% measurement. The amount of air volume that you have below that, because of a point, depending on what the chisel point is on the drill bit, you can have a little bit more air in that, or a larger volume of air. But from a differing results, It's usually not something we're going to see, or that the ASTM committee has really brought up to be something that's a huge issue. So again, measure from the outside shoulders of the hole. Calcium chloride test. Would it put a piece of the puzzle in regards to environmental conditions? I'm not 100% sure on this one exactly where we're trying to go with it. Calcium chloride, I mean, if you wanted to sit there and do all these tests, you definitely could. I think if I was going to make any kind of argument, it'd be that I'd be doing some kind of core test to verify, especially on new construction or on existing construction. I'd be doing a core test to verify, an intact vapor retarder, because I hate to say it, if there isn't an intact vapor retarder, then the test that you're taking today can change tomorrow. For me, if I was looking at from an environmental condition standpoint, personally, I'd be using some kind of data logging instrumentation so that I could actually see what the conditions were that were going on. So from an ambient condition, I would like to have an instrument that was on site that was measuring nothing but ambient condition and logging it over the course of the entire time that I had the test down, so I could sit there and say, yes, well, two things. If I was the one performing the test, I'd like to be able to prove that I did, in fact, meet those service conditions. Or if it didn't meet service conditions, I could at least bring that up to the commissioning party so that I could say, okay, here's the information I have as far as the relative humidity and temperature in the concrete, but it's based on these ambient conditions, which aren't service conditions. So having that, to me, is a bigger piece of the pie. Your company used to have an RH app. Now it seems it is just on your website. No, we definitely still have an RH app. It's called rhspec.com, and it's on Apple and Android. Sometimes when you're going through and searching, if you're having an issue finding it, sometimes when you're going through searching, there's an option, especially on the iPad. It can either be iPad or iPhone, as far as which apps you're searching for. Sometimes that's an issue. That RH Spec app is our attempt to try to have as many of the companies that are specifying relative humidity testing, as far as adhesives, finished floor products, things of that nature, to give people access to be able to just do a couple of, drop down menus and go off to the manufacturer's specific websites as far as where their guidelines are for moisture testing. And it seemed like that over the years I've spent a lot of time with people calling and wanting to understand that and know where that information was at, and that's where the intent of that RH Spec app came from. What are your thoughts on testing a slab on grade that does not have vapor retarder? Also, if the GC or anyone involved cannot determine the slab depth, what is the best method to determine the thickness without compromising the vapor retarder? So, I mean, I guess there's a few ways to think about it. So the thoughts on a slab on grade that does not have a vapor retarder, technically, at that point, if it doesn't have vapor retarder, most people will say you need to have a vapor retarder either below the slab or on top of the slab. So if we know there's not one below the slab, then you need to be looking at a vapor retarder that is going to be an absolute bulletproof, rock solid option on top. So you're looking for a product that is going to be E96 tested to be very, very effective as far as low permeability, and something that is going to be rated without any kind of loopholes to 100% relative humidity. So at that point, most of those companies are still going to require that you do some kind of testing. So again, that's where the philosophy comes from. If the GC can't determine the slab thickness, there's a couple of ways on that. They make a device. Unfortunately for most people, it's a little bit spendy. It works off of what they call an echo impact principle, and it is something that goes down on the surface of the concrete, sends some kind of signal through to the bottom, and it comes back and gives you an idea of what that is. I think the last time I looked, it was about plus or minus 1/4 of an inch from an accuracy standpoint. And last time I checked, it was about $2,500 for that device. On the other side, I tell people that, especially when you're doing renovations, things of that nature, you'll find that they're doing a lot of adjustments as far as adding plumbing, moving plumbing, trenching, things of that nature. Being able to see an open trench like that will give you some information. On the other side of it, at the end of the day, you're going to hear most people say a couple things. One is, if you drill a smaller pilot hole all the way through the slab, a lot of times as you're getting to the bottom of the concrete, much like when you do with wood, you can feel when that bottom end is starting to give out. And you just don't push the drill as gingerly through the bottom of that. On the other side, if you do, and you poke a hole in that vapor retarder, again, I would say that if that's the worst thing that's ever happened to a vapor retarder that's underneath the slab, that you've probably done a very, very, very good job. With that, then you have the ability to determine thickness. Now, I would never say, and I don't think anybody ever does, I would never say that you want to go through and make a slab into Swiss cheese, but you want to end up being able to have a couple of different comparative data points to be able to make sure there isn't some huge inconsistency from one side of the building to the other. RH is used in conjunction with other test methods. Do you find the other test methods mute to your probes? Well, what I can say is that if I was going to use one test, which in the real world it seems like is about what people have the opportunity to use, that I'm going to use the test that has science behind it that I know is going to not have as much bias to ambient conditions or sways in ambient conditions. And with that, if I was going to make a decision based on something, it's going to be based off of relative humidity testing. It's about the most I can say. The problem I have is that when you sit there and try to put 15 different tests on there for moisture testing, you find out that people are going to do less and less and less of it because it becomes too cumbersome for them to even do it. And I'm just talking real world. So, with that, for people to be able to have the best sense of what the potential issues are going to be, or potentially what the issues can be for the floor, relative humidity testing is going to be the one to use. So it looks like that's all the questions that I have for today. Again, my name is Jason Spangler. My phone number is 800-634-9961, extension 235. If there's any questions that you have, or any clarifying points you need to the answers that I gave, please don't hesitate to give me a call. Thanks, and have a great day.